Hey guys, welcome back to the Makefile series. This is the second video, and we're going to be talking about how to write a makefile for a simple C project with multiple source and header files. So basically the makefile you see on screen here. In future videos, we'll make improvements on this and we'll get to more advanced makefiles, but for now, let's start off with this simple project. So first, let me explain what this program does. I'm going to close the makefile, so we'll write it from scratch later. We have main here, and all we do is we print hello world. So I've split this off into two functions, print hello and print world, and they have their own files. So header files here and source files here. In the header, we have the declaration, and in the source file, we have the definition. So we print hello, and before that, we actually print common. So all common is this thing here that prints out the time. You don't have to worry about what's going on. I just wanted to add one more file to make it more complicated. So in our header files, we have the declarations for hello and world, and this is what we have for common. And what we want to do is we want to write a makefile that is going to pick up any changes that we make to the header files or to the source files, depending on what you're compiling or building. Now, if we want to compile this without using a makefile, what you can do is you can do gcc-o steal, for example, for the application name, and you can do star.c. And what that's going to do is it's going to match all of the C files, and it's going to compile and link them together to create the steal application. And if you run it, you can see hello world. So that's just the time. Now, this is not the approach you want to take when you're working on larger projects, because over here we're recompiling every single C file. So if I make one change to hello, you don't want to recompile every single file one more time. You only want to compile this hello file over here. So to do that, what you do is you split the building into compilation and linking stages. So you can compile with gcc-c to stop at the compile stage, and you can do hello.c. And what that'll do is it'll create a file hello.o. This is the object file. When you do this for all of the files, gcc-c and then star.c, you'll have all of the .o files, and then you can link them together like this. And now you have the new Steal2 app. So in this example, I took a shortcut with the star.o, but in the makefile, we'll do things properly. Now, let me undo my changes so we can start from scratch, and I'll erase this makefile so we can really learn along the way together. In our final executable, what we want to create is a file called steal. This is the application. And the way we create that, let's skip to the recipe, is we want to write gcc-o steal, and we want to include all of the object files here. So that's going to be main.o, hello.o, world.o, and common.o. These four files are what you need to link together, so they are also going to be your prerequisites. And all of your prerequisites need their own rules. So let's do that. And now for each of these files, we want to compile them. So we're going to do gcc-c, and then for main.o is going to be main.c. For hello.o is going to be gcc-c hello.c. And now this has the basic structure of what you need for your makefile, but we still need to add the prerequisites for these guys. So obviously we know that to compile main.c, you need a prerequisite on your main.c, because if you change this main.c, then you know you need to recompile it. And same for the others, but we're not done just yet. So the way our source files interact with other source files are through headers. For hello.c, we have the hello.h header, and we have that included here in main. What this is a preprocessor statement. So the contents of hello.h are copied and pasted into this line over here, and we repeat the same thing for world. So we know that whenever hello.h changes, when we're recompiling this main.c is also indirectly changed. So we go to the makefile, and in addition to main.c, we add hello.h and world.h. We repeat the same for hello, world, and common. So in hello, we included hello.h and common.h. For world, we included world.h and common.h. And for common, we probably just included common. Now, technically, we also could include these, but these are system headers and they're never going to change, so you don't really need to include them at all. And that's it. Now, if we run make, it's going to compile hello.c because we had removed that extra hi, and it builds the application. If we run make again, it's going to say steel is up to date. If we change common.c, for example, if we update the last modified time, and then we run make, it only compiles common.c. What happens if we update the last modified time of common.h? We had to rebuild hello.c, world.c, and common.c. So we rebuilt these three, but we didn't have to rebuild main. Even though this indirectly depends on common.o, it doesn't directly depend on it. This guy links to common.o to create the final application, but there's no compilation requirement for on this common file. Now, what would have happened if instead of having this common.h included in hello.c, what would have happened if we had it here instead? Now, from the perspective of hello.c, it would be the same exact thing. We include hello, and the first line here, it's going to skip these defines. The first step is we're going to include common.h one more time. So there's no difference from this perspective here. But from main's perspective, now we have an additional include. This include is recursive. So we included hello, and then hello included common, and we have to update that in the makefile. So if that were the case, we would have had to add common.h here when we're building main.o. So because of that, you don't want to take that approach. You would prefer to keep your includes only where they're really required. So that's all for this video, but we can still add one or two more things. First off, let's add a rule for clean. And this is the industry standard. Everyone adds a rule for clean. And what it does is it just removes all of your .o files and your application. So any file that has been automatically generated, this rule is meant to clean that. Sometimes you have all of these things put into a different directory, in which case you just delete that directory. But here, this is what we need. I like to have the -f because if this file doesn't exist, then -f doesn't report an error. It says it's okay. So if you're running it and that file doesn't exist, like I don't really care if the clean rule fails. Now, if we run make clean in this directory, let me manually remove steel 2. If I run make clean, we're back to the files that we started with. One more thing that's kind of standard that everyone does is you add a target named all, and you just have it depend on your main target that you really want to build. So people usually they just get a new project and the first thing they do is they run make all, and the expectation is that it's going to build whatever you want to build by default. Also, let me remove this common.h. And as always, this code is going to be up on GitHub. I encourage you to go around and play around with it. Try removing some of these prerequisites and make a few changes in the code and see what breaks and what doesn't break. You'll be surprised, and it's a learning experience. So in future videos, what I hope to do is start using variables and start using automatic rule generation, automatic prerequisite generation. So these things here, we manually wrote them in. But you can have these things automatically generated, and you can have all of these rules automatically generated as well. That's going to save you a lot of time, but you have to know how to do it. So keep watching and hope to see you next time.